Greetings, students. We're going to discuss practice test 1 for college prep math here. So question 1. If you're in the other two classes, this is Mr. Torgerson. If you're in the other two classes, you're going to graph this on a graphing calculator. My class, what I want you doing is making me a table of values. Starting at -2 and going to +2. So those 5 values. What I'm checking here in my class is whether or not you can use a calculator effectively, or efficiently, I should say, to plug numbers in. So, to get the x to the 4th, we're going to do parentheses, -2 to the 4th. To get the x cubed, we're going to do parentheses, -2 cubed. And I guess I should show you, as I'm doing this, the calculator more effectively. So there we go. So we have the -2 parentheses to the 3rd. There's -2 cubed. To get the minus, -2 squared. There we got that. And then the -2 at the end. All right, we'll go through it again, look through the whole thing again. Make sure you typed it in right. -2 to the 4th, the quantity -2 to the 4th, quantity -2 to the 3rd, minus the quantity -2 squared, -2. That is 2, that output. Now, once I've typed it in once, the function, I don't have to go back and type in the whole thing again. I just have to change the numbers. So now the next number I want is -1. So I'm going to go back and change these -2s into -1s. So -1 to the 4th, -1 to the 3rd, -1 squared. So that's going to yield a -3 now. Then I'm going to type in 0. Now, when x is 0, we end up with the y-intercept. So I can just let that be -2. I don't have to do work there, really. And then type in 1, type in 2. +1, +2. So delete the negative signs. +1, +1, +1. And there we have -1 for that output. And then +2. With these, again, it's important that you take your time, type it in the function, make sure it's typed in properly, because it's difficult to check if you type things in right. I mean, you could work these out by hand, one of them at least, and make sure it matches. So like maybe I work this one out, 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16, plus another 8 is 24, minus the 6, which is -4 minus 2 is 18. So that might be something you can do. All right, what type of symmetry does y equals 4x squared have? So again, you're checking when you put in -y, does it stay the same? When you put in -x, does it stay the same? Or when you put in negative for both, does it stay the same? Or you can also look at the graph of this and see if it folds over the y-axis, over the x-axis, or over the line y equals x, the origin. So in this case, y equals 4x to the 2nd. This will fold over the y-axis. It's got y-axis symmetry. In other words, when you put in -x, it's the same as +x. The opposite of x is the same as the regular x. So when I put in -2, it's the same as +2. 4 times -2 quantity squared is the same as 4 times +2 quantity squared. Whereas if I put in a -y, it's not going to be the same. When you have opposite for y, it's not the same value for x. So for example, if y was 4, you get x equals 1. If y was -4, you would get x doesn't work. There'd be no answer for x. All right, next one. Standard form of a circle, x minus h squared plus y minus k squared is equal to r squared. Don't forget r squared here, and that h and k are opposites, so it should not be x minus 4, it should be x plus 4 squared, and it should be y plus 11 squared is equal to 25. 5 squared. That's it. All right, so that's the 3 questions on the first page, questions 1 through 3. Moving on to page 2. All right, identify the center and radius, and then graph the circle. All right, so the center, remember it's opposite of h, so it's +4, not -4, and opposite of k as well, so it's -2, not +2. So 1, 2, 3, 4, down 2. Radius is going to be 1 in this case. Now, remember, we're square rooting that number at the end, so this is maybe not a good example because it's a 1 at the end. But if it was a 16, it'd become a 4. you're square rooting this radius. All right, then you plot from the center, you plot up, down, left, and right, the radius. So up, down, left, and right. And we have our circle when we connect the 4 points on the circumference along the circumference of the circle. All right, question 5. Solving equations, you're going to distribute. 87 is equal to 10v, that's a v, plus 16 plus 1. 16 plus 1 is 17. 87 is equal to 10v plus 17. 17 from 87 is 60. Or 70, sorry. I'm a little tired this morning. 70 is equal to 10v. And then dividing by 10, v is equal to 7. All right, next one. You're going to multiply by the denominators to eliminate the denominators. So I'm going to multiply everything by 5 and v squared. That's going to cancel out the v squareds here and here. It's going to cancel out this 5 here. And then this one here is going to have a 5 left over in the top. It's going to be 5 times 1 because there was no 5 in the bottom. So I have here 5 times 1. This one is lacking a v in the denominator. So it's going to be plus 5. That's going to be 5v times 1. And this one here on the right, the last one, has everything in the bottom, as the 5v and the squared. So this is going to be simply equal to 4. All right, so this will be 5 plus 5v equals 4. 5 from 4 is 1, negative. And dividing negative 1 by 5, you get negative 1/5 as our answer. All right, you can check your work by plugging the number in. So if we put in negative 1/5 for v, we get 1 divided by negative 1/5 squared plus 1 divided by negative 1/5. And that equals 20. And then we can do 4 divided by, parenthesis, 5 times negative 1/5 squared. 20. All right, next one. Distance equal weight times time. So what I'm looking at here, first thing I see is a time, 4 hours. So I got D is equal to RT. So I've got a 4. All right. She averaged 16 miles an hour faster on the return trip than on the trip to the cabin. Find average speed to the cabin. Ooh, so this one's a longer question. It does have 2 D equals RT questions, but it requires a little bit of extra thought. So the distances are the same for both. So I have D equals RT for both. So this one's times by 3. The trip back took 3 hours. I don't know the rates, either of the rates. So I didn't give you an exact for each of the rates. She averaged 16 miles an hour faster on the return trip than she did on the trip to the cabin. So what I can do here is I can set these two equal, but I have to call one of these rates x, and then the other rate I have to relate to it. So let's say that the rate there was x, or we can just use r if we want. R times 4. This rate here is going to be r plus 16. R plus 16 because it's 16 miles an hour faster. And now I can set these two equations equal to each other because the distances are the same. The distance to the cabin and from the cabin will be equal. So I'll set 4r equal to 3r plus 48. We distributed the 3 to the r and the 3 to the 16. So r will equal 48 miles per hour. So on one direction she was traveling 48, and then the other one she was traveling 64. We wanted the speed to the cabin, so 48 is the one we wanted. You can check your work by doing 48 times 4. 48 times 4, which is 192 miles in this case. And then do 48 plus 16, which is 64. times 4. Or times 3, sorry. Because they only travel 3 hours in that direction. 192. So that's how you can do this problem. That's one way you can approach this problem. There's other ways too. Would work. All right, factoring at the bottom of this page. Again, I do X factoring. If you do a different type of factoring, that's fine as long as it's factored, as long as you can factor. So my goal here is to make -7 when it multiplies. Well, there's only 2 ways to make -7. 7 times -1 or -7 times +1. They have to add to make -6. Well, -7 and +1. Not +7, -1. That's +6. So x minus 7 times x plus 1. That's the quick factor variety, the easier of the two. The longer factoring one, you can do this by completing the square if you want, or you can do it with factoring, which is what I asked you to do. So here, we're going to take a times c, 6 times 14. That's going to go on the top. 6 times 14, 84. Our goal is to make -5, and it's -84. So perhaps I'll start off with 4, because this 8 and 4 both divide by 4. So maybe I'll start with 4 times 21. Now those would subtract to make -17. So I'm going to go bigger than 4. So maybe instead of 4, I'll try 6. And again, I can use a calculator to assist me. 84 divided by 6. 6 and 14. Still too large because 6 minus 14 is -8. So I'm going to go larger than that. So maybe I'll try 7. 7 and 84. 84 divided by 7. 7 and 12. And that's the one I need. With the 12 negative, 7 positive. So -12, +7. Now again, there's multiple approaches here once you get to this step on what to do. You do have to bring the a out of the 12, and you have to accommodate for the a with the 7. So one of the approaches you could use is to write this as 6x plus 7. 6x because it's a 6 for the a. Here I just had n. Sorry, it's not x, it's n. And so 6x plus 7 times the quantity 6x minus 12. If you do this way, make sure you factor out the common item here and eliminate it, because we don't want the 6 included there. So since both those divide by 6, it's not going to be 6x minus 12 on that second factor. It's just going to be x minus 2. I did say to solve both of these, so I factored it. Now I'll solve them. Adding the 2 over, that's x equals 2. And then subtracting 7 divided by 6, that's x equals -7/5. I forgot to do the last step on here. And here, this is n equals -1, and n equals +7. Don't forget to finish it, like I did, as I might not give you full points if you don't finish by solving. All right, next page. Question 10. Solve by taking square roots. So what you're going to do is you're going to isolate the square by moving the number over to the other side. Let me tape this paper down so I can write it a little bit easier. So I don't have to hold it as much. Okay, there we go. So you're going to take the 3 from the 52. Now on the test, this may or may not square root evenly. So here it does. 49, when you square root 49, it becomes a 7 or a -7. So x is equal to positive and negative square root of 49. If it doesn't square root evenly, what I'm asking you to do is to give me a decimal approximate or reduce it if it does. Which is a good example because the next one. Adding 5 to -9, we get -4. So here's an example of a complex number. So when we square root -4, we do get positive and negative. Square root of -4. And the square root of -4 is not 2, it's 2i. Plus and minus 2i. That's the finished answer we're looking for here. All right, for the ones that say complete the square, I don't care if you factor them, if they're factorable. This particular one does not factor, so you do have to complete the square here. But if they are factorable, you're welcome to factor them. You're also welcome to use quadratic formula if you prefer to use quadratic formula here. I just care if you can solve this. So I will complete the square here by adding 16 to both sides. So n squared plus 8n plus 16 equals negative 47 plus 16. I moved the 47 over to the other side so I could isolate the root. So I could isolate the root here, or the squared, I should say. Sorry. This will factor to n plus 4 squared, and this will make negative 31. Square root both sides. N plus 4 is equal to positive and negative square root of negative 31. And then subtract the 4 over. N is equal to negative 4 plus and minus the square root of negative 31. Now that negative 31 square rooted becomes I root 31. It does not root evenly, so I'm not going to take the root of negative 31, but it does reduce by bringing the I in the front. Negative root should have an I in the front. All right, quadratic formula. Again, if this is factorable, you're welcome to factor it. So we can do this 9x squared minus 11x minus 6 plus 6, sorry, equals 0. And I can try to factor that. Well, that would be 54. And to make 11 from 54, we could try to make 11 from 54. Well, 9 and 6 is the first factor, which is 15. So I'd have to go bigger than 9 into 54, which is not possible. Because 8 won't go into 54, and neither will 7. So we're going to have to do quadratic formula here. So x is equal to the opposite of b, positive 11, plus and minus the square root, b squared, 121, minus 4 times a times c, so 4 times 9 times 6. 4 times 9 times 6, 216. All over 2 times a, 18. So 121 minus 16. Sorry, 216. Is negative 95. So 11 plus and minus the square root of 95, negative 95 divided by 18. I'll move the I in the front of this and it'll be done. 11 plus and minus I root 95 divided by 18. All right, simplify I to the 45th. Remember, I to the 4th equals 1. So what I'm going to do is I'm going to divide 45 by 4, figure out how many times it divides evenly, and then find the remainder. So 45 divided by 4 divides 11 times with 1 left over, 1/4 left over. So what this is it's I to the 4th to the 11th. There's I to the 44th times I. So in other words, this is 1 to the 11th times I. 1 to the 11th times I. This is just simply I as my answer. Since every I to the 4th power makes 1. In other words, since every 4th power of I is 1. Alright. We're at an inequality that represents the sentence. The product of a number x and 5 is at least 30. Product means multiply. So this is x times 5 or 5x, either order. It's a little weird if you write it as x times 5, but 5, that's fine. 5x, x times 5, is at least, so that means it's greater than or equal to 30. I didn't ask you to solve the inequality, but if you want to tell me that x is greater than or equal to 6, that would be good. That would be peachy. All right, solve the inequality. Distribute the 5 to the 3 and the negative 7. So 85 is less than 15 minus 35n. 5 times 3 is 15. 5 times negative 7 is 35n. 15 from 85 is 70, which is less than negative 35n. Dividing by negative 35 switches the sign, and it becomes negative 2 is greater than n. In other words, n is less than negative 2. So here's negative 2. We want numbers less than negative 2 to satisfy this inequality. You can check, see if you did your work properly. Sorry, that's positive 2. Negative 2. Less than negative 2. What we're saying here is numbers that are greater than negative 2, won't work. So if I put in a 0, this would not be true because 5 times 3 is 15. So 0 does not work. So that's the way we want the arrow to point. We want it to point left from negative 2. And if I put in a negative 2, you would have 5 Well, this will be 3 plus 14, which would be 17. 5 times 17, that would be 85. That's where it cuts off, yeah. 85, 85 on each side. And I can't have it equal. It's got to be less than. 85's got to be less than the expression. All right, one more page. Graphs of lines. So this is the same as you did in Algebra 1. These are not any different from Algebra 1 pre-algebra questions, these questions here. So these should not be an issue getting right. Sketch a graph. You do slope-intercept form on this first one. M is 3/5, in other words, up 3 over 5, and B is 2. So starting at 2, go up 3 over 5. Connect the dots, and you've got your line. Here with the intercepts, this is a different type of graph. You plot them on the x and the y axes. X-intercept goes on the x, so -2 on the x. Y-intercept goes on the y, so -3 on the y. Connect the dots the same as before. This does have a slope of right 2 down 3, so +2, -3, so 2/3 negative. Sorry, I should do the y first. Down 3, down 3, right 2, down 3, so -3/2 slope. Down 3, right 2. All right, question 19. M is -7/4, so down 7 over 4, starting at the b value of 3. 1, 2, 3, down 7 over 4 to the right. 1, 2, 3, 4, 5, 6, 7 over 4 to the right. There we go. So sorry. Oh, you can see that one. Sorry. I thought I was looking at number 20. Down 7 over 4. And then this last one, it says write the slope-intercept form of the line. So this is y equals mx plus b, same as it's always been. Y is equal to -1/2 x plus 2. There you go. I'll be here before and after school on Tuesday, Thursday. And if you make an appointment, I'll be here another day as well. Please come in if you need help. Good luck.